Okay, so in this video, we're going to be talking about the malate shuttle. So what is the malate shuttle? Okay, so we talked before about the process of glycolysis, and we said that one NADH molecule is produced in glycolysis. Now, this NADH molecule needs to enter into the mitochondria and reach the electron transport chain, donate its electron in order to help produce ATP. The other thing that we talked about is the formation of oxaloacetate inside of the mitochondria. We said that pyruvate can be converted into oxaloacetate in the process of gluconeogenesis. Now, this oxaloacetate, in order to finish the pathway of gluconeogenesis, it needs to exit the mitochondria and enter into the cytosol. So, how does NADH enter the mitochondria and how does oxaloacetate exit the mitochondria? And this is going to be done by the malate shuttle, and this is going to be the discussion of this video. Okay, let's get into a little bit of detail. So now we're going to discuss how the NADH is transported from the cytosol into the mitochondria. So this upper part right here represents the cytosol, and this inner part represents the mitochondria. This is going to be the mitochondrial membrane, and this purple thing right here represents the malate shuttle. So like we said, we have an NADH molecule, and we want to get it inside the mitochondria so it can go to the electron transport chain and produce ATP. So how does this happen? Well, the first thing that's going to happen is that an oxaloacetate molecule in the cytosol is going to be converted into malate. And in the process, it's going to consume one NADH molecule and produce one NAD plus molecule. Now, malate, of course, has the ability to go through the malate shuttle and enter the mitochondria. But we still don't have an NADH molecule inside the mitochondria. So what's going to happen is that malate is going to be converted into oxaloacetate. And in the process, of course, it's going to consume one NAD plus and form one NADH. So like you can see, at the end of the process, we have transported one NADH molecule from the cytosol inside the mitochondria. So now this NADH molecule can go to the electron transport chain, donate its electron, and produce ATP for the cell. Okay, so now we're going to talk about how the malate shuttle helps in oxaloacetate transport. So we said that oxaloacetate is formed inside the mitochondria. But in order for oxaloacetate to help or to enter or to finish the process of gluconeogenesis, it needs to exit and enter the cytosol. So how is this going to happen? Okay, so oxaloacetate is first going to be converted into malate inside the mitochondria, and it's going to consume one NADH molecule in the process. Malate, of course, has the ability to use the malate shuttle, and it's going to exit the mitochondria and enter the cytosol. Malate is then going to be converted back into oxaloacetate. It's going to consume one NAD plus molecule and form one NADH molecule, and oxaloacetate can now finish the process of gluconeogenesis and form glucose.